right, today we're going to discuss on the non-parametric methods on nominal level of hypothesis test. Okay, first of all, what does it mean non-parametric? Okay, you may have some questions. The means of the non-parametric. So non-parametric usually is a statistical test which is not involved. Okay, so not involve any of the assumptions as to the perform of the parameter of the frequency distribution. Okay, there is no any assumption is carried out. Right, that's what we call as a non-parametric. So in this lecture, we will focus on that what type of the non-parametric methods, okay, we use, especially for the nominal level hypothesis test. Okay. So mainly we're going to discuss on the topics, all right, to test that the hypothesis, okay, comparing an observed set of the frequencies to an expected frequency distribution. So we're going to do that the test based on that, the observed set of the frequency to an expected frequency distribution. So this is mainly we're going to touch into it. And then we're also going to explain the limitation, okay, the limitation of using the chi-square statistic. Okay, I'm sure you all know about the chi-square. All right. So this is one of the statistical tests we widely used. Okay, so for the unsymmetry data. Okay, so chi-square statistic as well as in the order to calculate the goodness of the fit test. Okay, how the goodness of fit test is calculated in the chi-square. And then we also look into that the independence on the contingency table. Okay, so this is the main important topic we're going to discuss in this lecture. Right? All right. Now, first of all, we take a look on the test hypothesis comparing an observed set of frequency to an expected frequency distribution. Okay. So as usual, we need to know that the hypothesis, right? So we have a two type of hypothesis. One is the null hypothesis. Okay. Another is a alternate hypothesis. Okay. All right. So hypothesis usually for that the comparing observed and expected frequency will be written in this way. Okay. The null hypothesis usually sounds there is a no difference between observed and expected frequencies. That's a standard way how we need to write the null hypothesis in that observed set and the expected frequency distribution. Okay, so which means is that they're saying that there is no difference between observed and expected frequency means that the two frequency distribution are not different. So which means the same. So that is usually how we do that the null hypothesis statement or that the when you're comparing the observed and expected frequency distribution. Okay, the alternate or alternative hypothesis or hypothesis alternative, the gains on that hypothesis null. So we just write that there is a difference. Okay, there is a difference between observed and expected frequency. Okay, the null hypothesis we have no, but we against that null hypothesis on that alternative hypothesis, which is we claim that there is difference between observed and the expected frequency. Okay, in other words, we say that there is a difference frequency between the two frequency distribution. Okay, so there is a difference between the two frequency distribution, which is observed and the expected frequency. All right, so you need to know that the way how we need to write that the null hypothesis and the alternative hypothesis. All right, for the case observed and expected frequency distributions. All right, moving on. All right, in chi-square statistic, all right, usually we use in order to test the hypothesis comparing the frequency distribution. Okay, so when we just come to that comparing that the observed and the expected frequency, So it's very common. We use the chi-square statistic. All right. So chi-square statistic. So chi-square statistic usually will be denoted as like this. Okay. So the chi-square will normally will be they denote as is a Greek letter of x square. All right. So it's we call a chi. All right. Chi-square statistic. All right. Now let's see what is the major characteristic of chi-square distribution. Okay. So let's see the characteristic of the chi. Okay, first thing is you need to know that the chi-square is a positively skewed. Okay, it's a positively skewed. So this is the first thing you need to know. This is one of the characteristic of that the chi-square distribution. Okay, so you see that the curve. Okay, the curve is just is going down. All right, straight. Okay, it's a positively skewed. Okay, it's a positively skewed. Okay, it's not touched that the x-axis. Remember. Okay, so the main is shift towards on the left. Okay, and we call it is a positively skewed. Okay, next, it is non-negative. Okay, the value obtained should be non-negative. Okay, it's non-negative values. Okay, and then the shape of the distribution depends on the degree of freedom. Okay, so you can see that if the degree of freedom is smaller, and then you just all right, you shift to left. If it is the degree of freedom is larger, then it tend to become a normal distribution. Okay, so as much as is larger the degree of freedom, then the chi-square will be approach to that normal distribution. Okay, so you can see that the trends. All right, so degree of freedom 3, 5, 10. So you see that it tend to be a normal. Okay, so you should understand that. These are three characteristics. All right, is in the chi-square statistic. Okay. Now we're going to look into the goodness of fit test. Okay. And before that, you need to know a few elements, right? Before we carry out the goodness of fit test. Few elements. One is that the F naught and FE. Okay. So F naught is observed frequencies. And then the FE is expected frequencies. Okay. All right. So the variable K is the number of categories. Right? So the variable K is the number of category. Usually how we carry out in the previous test, right? That D statistic, okay, Z statistic, and so on. So K is the number of categories. Okay. All right. The test statistics usually denote with the chi-square equal to sum of in bracket F naught, this is observed frequency, minus expected frequency all square over your expected frequency. Okay, so then you can find that the chi-square value. Okay, all right. So remember that the computed value, okay, the value which is computed in the bracket, right? For each category is sum of all the categories. Okay, so you say this is just a first category, second category, you need to sum up everything. Okay, so it's just given in the general forms. Okay, if there are many categories, then you need to sum everything up. Okay. Okay, now take a look at this example. All right. Okay, the Buba fish and pasta is chain of the restaurants located along the Gulf Coast of Florida. Baba, the owner, is considering adding steak to his menu. Before doing so, he decided to hire Magnolia Research. Okay, so they hire that independent research center in order to conduct a research survey. And then what they have done, uh, Okay, the Magnolia research is conduct a survey of adults about their favorite entries when eating out. So Magnolia selected sample of under 20 adults and asked each to indicate their entries when dining out. The results are reported as below, and Winona is responsible to conclude there is no preference among the four entries. So he didn't ask, is it reasonable to conclude there is no preference among the four entries? So this is what the main questions and objective we're going to do in this code. So we have a sample which is about under 20 adults. All right. Okay. Now, all right. So this is the data we have. Okay. We have a four category: chicken, fish, meat, and pasta. And we have observed frequency as well expected frequency. So the chicken, we have 32, fish 24, meat 35, and pasta 29. And we add them up is under 20. So we tally. And what they expected frequency is all 30. So we have 20 and 20. Okay. All right. So as we know that expected frequency distribution is to infer that adult have no preference for the any of the entries. Okay. And the probability that an adult would choose any entries are equal. Okay. All right. So this is what we obtain here. All right. So we take that under 20 divided by 4, we got a 30. Okay. All right. Now we're going to set up the hypothesis test. Okay. So first of all, what all you need to do? First, you need to set the hypothesis null and the hypothesis alternative. So you can say that hypothesis null, there is a no difference between the expected and observed frequency. Okay. So that your alternate, your null hypothesis, you already set up. And then the alternative hypothesis, you say there is a difference between the observed and the expected frequencies. So this is your alternative frequency. So you already set up these two statements. Now, we're going to check on this. All right. Remember, as you know, all we're going to do is we're going to prove or reject on that alternative hypothesis. Okay, here we go. Step 2, you need to choose the significant level. As we know, in the research level, usually we take that the 0.05 level of significance, or in other words, we take the 95%, okay, in the significant levels. So we need to set that the critical values. Okay, so your level of confidence, which is 0.05. Okay, next. See, this is, as we know, this is the chi test. Then we need to take the tail between on the right hand side. Okay. Now, third step is you need to select the test. Okay, for sure, since we considering that observed and expected distribution, so we choose that the chi-square distribution. Okay, so we will stick to that. And then step number 4, you need to formulate that the decision rules. Okay, so you need to formulate the decision rules. So how are we going to make the reference rule? So you need to know that the critical value, what is the critical value is there. Okay, so we have that 0.05. Okay, so we need to check in that the chi-square table. Okay, so when you look at the chi-square table, all right, and we need to know that the degree of freedom. So degree of freedom, usually we do k minus 1. Okay, so we have a 4 category. Okay, k is 3 now. So k is 4. So 4 minus 1 is a 3. So I mean we have a 4 category: fish, meat, chicken, what else? Pasta. All right, we have 4 category, but as we know that we need to choose, we need to set the degree of freedom. So k minus 1, so 4 minus 1 is a 3. Okay. All right. So we already said that the degree of freedom. So you need to look into that in the chi-square table, okay, in order to determine the critical value. Okay, now how are we going to reject that hypothesis null? Say your computed value, your chi-square, okay, your chi-square is greater than the critical value. So this is a critical value, CV, critical value. So the critical value we obtain from the table. Okay, this is we can obtain from that table. Okay, all right. Now, so what we're going to determine now, so when you check the chi-square table at the point, the confidence level 0.05 and the degree of freedom is 3 and the value is 7.815. So this is your critical value. Okay, so this is your graph, all right? Okay, oops, graphs looks ugly. Okay, so critical values here is 7.815. Okay, so this is your critical value. Okay, all right. Now, so yeah, this is how you're going to check in that the value from the chi-square table. Okay, so at the point here is your level of confidence. Okay, so you need to look on the right hand side because since it's a chi-square table, so 0.05 and the degree of freedoms that you know is 3. So you can see that the intersection of the 0.05 and 3 and you get a 7.815. Okay, now, so we already know that the critical value at this point. Okay, so whatever the value, I mean the chi value, the chi value we calculate later. Okay, so say this value when we compute is greater than 7.815, so then we tend to reject that the hypothesis null. Okay, say the computed value is fall in here, okay, beyond the 7.815, then we tend to reject that the hypothesis null. Okay, if it is less than 7.815, then we do not reject that null hypothesis. Okay, this is the idea. All right, now, so moving on. So we're going to calculate using a formula. All right. So we all know that the observed value, okay, this is step 5. We're going to do the test analysis based on the chi-square formula. Okay, now we're going to calculate chicken is 32 and the expected is 30. All right, with all this data. And then first thing you need to express in the form, okay, in the form of table. All right, your observed frequency minus your expected frequency. So observed is 32 and the expected is 30. So 32 minus 30 is 2. Okay, likewise, you can drag so you can get all the values. Okay, so 24 minus 30, you get minus 6. 35 minus 30, you get a 5. 39 minus 30, you get a minus 1. All right. Next, you need to all square all this value. You get a 4, 36, 25, and 1. And then you need to divide it by that expected frequency. Then you get all these values, 0.1, 33, and so on until you need to add them up. Okay, add them up. All right, you get a 2.200. Everything. So now you need to compare this value with the critical value. Okay, so as we know, the 2.200 is less than the critical value, which is we obtained from the table, which is 7.815. So that means that the decision, we can say that we failed to reject the hypothesis null at the significant level, which is 0.05. Okay, so which means we can claim that there is no difference. Okay, there is no difference in that observed and expected value.